Hello, everybody. So we're going to continue our discussion of volume in lesson 11.6. We're on page 487 of the fifth grade Go Math textbook. And our essential question is, how can you use unit cubes to find the volume of a rectangular prism? And we sort of talked about that in the last lesson, but we're going to continue that discussion. So remember, you can find the volume of a rectangular prism by counting unit cubes. Keep in mind that volume is the measure of the amount of space a solid figure occupies and is measured in cubic units because there's three dimensions. We'll have length and width, and we'll also have height. So each unit cube has a volume of 1 cubic unit. It has a length of 1, a width of 1, and a height of 1. So if we're looking at this rectangular prism, it's made up of how many unit cubes? Well, they've placed numbers on these. Okay, so we have 4 in this row and we have 4 in this row. So that's a total of 8 cubic units. Well, there's only one layer, right? So it has a volume of 8 as well. All right, so now in this one, you'll need a rectangular prism net. It's a cube basically. So we need a prism net that's a cube. And you need centimeter cubes. So these are some supplies that you can get from your fifth grade teacher, or you can go online and find a net for a cube. Okay, so I cut out, folded, and taped the net. So I have a cube here. Okay, and I cut off the top so that I could fill the space and you could see that. All right, so we're going to use centimeter cubes to fill the base of the rectangular prism without gaps or overlaps. Each centimeter cube has a length, width, and height of 1 centimeter and a volume of 1 cubic centimeter. So fill in the bottom layer. And so how many do I have? I have 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, and I only have one layer. So the length is 5, the width is 5, and the height is 1. So how many cubes are there? Well, if you have 5 by 5, 5, 10, 15, 20, 25. So I use 25 unit cubes to fill the bottom layer of this cube. Okay. Now, we're going to continue filling the rectangular prism layer by layer, and we're going to count the number of centimeter cubes used for each layer. Now, keep in mind, right? Each layer is going to be 25 cubes. Okay. So if I put another set of 5 by 5, okay, so that's my second layer. I'm just going to keep track here with some tally marks. Okay, so I've put 2 layers in, and now I'm going to add a third layer. Another set of 5 by 5. All right, now we have 3 layers in our cube. I still have space, so I'm going to add another layer. All right, now we're at 4 levels of 5 by 5. And it looks like I have enough space for one more row or one more layer. Okay, so yeah, I have 5 layers of 5 by 5. Okay, so how many centimeter cubes are in each layer? 25. How many layers of cubes did I fill it with? 5. So how many centimeter cubes did I fill the prism with? Well, I have 25 times 5 sets of 25. So it takes 125 cubic units to fill that cube. So that means it has a volume of 125 cubic centimeters. So this cube here has a capacity or a volume of 125 cubic units or cubic centimeters. So let's look at page 488. Okay. So describe the relationship among the number of centimeters cubes you use to fill each layer, the number of layers, and the volume of the prism. Well, so what did we do? We said the number of centimeter cubes in each layer, which was 25, right? Each layer had 25 cubes, is multiplied. I multiplied that by 5, so or by the number of layers. All right. So the number of cubes in each layer was 25, right? So each layer had 25. We were able to put 5 layers of those 25. So that means the height of this cube is 5. So basically we have a 5 by 5 by 5. And 5 times 5 times 5 is 125. All right, number 2. If you had a rectangular prism that had a length of 3 units, a width of 4 units, and a height of 2 units, how many unit cubes would you need for each layer? Well, if we had a length of 3, right, and a width of 4, okay, so I have a 3 by 4, that's 12 units, right? And if we had 2 units tall, it would be 24. So how many cubes do I need for each layer? 12 units for each layer. And I would need 24 cubic units to fill the prism. So 12 cubic units for each layer and 24 cubic units to fill the prism. Actually, I'm just going to say 20. I'm just going to need 12 unit cubes for each layer and 24 unit cubes to fill the prism. All right, so now let's make some connections here. To find the volume of a three-dimensional figure, you measure in 3 directions. For a rectangular prism, you measure its length, its width, and its height. And volume is measured in cubic units, such as cubic centimeters, cubic inches, cubic feet, so on. So which has a greater volume? 1 cubic centimeter or 1 cubic inch? Well, that should be obvious that a 1 cubic inch is longer than 1 cubic centimeter. So think of it as if we were filling this with centimeter cubes. In this case, it would only be able to have one. I would be able to put more of these 1 cubic centimeters in the space that would fill 1 cubic inch. Okay, so I can pour more into 1 cubic inch than I can into 1 cubic centimeter. All right, so find the volume of the prism if each cube represents 1 cubic centimeter, 1 cubic inch, and 1 cubic foot. All right, so here we notice that they're just units. So we're basically going to redo this with 2 centimeters, 6 centimeters, 3 centimeters. And then we're going to do it again and find it with 2 inches, 6 inches, 3 inches, and then 1 foot, 2 feet, 6 feet, and 3 feet. We're going to get the same number because the number didn't change, just the units changed. All right, so on our base, the area of the base is just the length times the width. So I'm going to go 3 times 6. So I know that there's 18 cubes or units in each level. And I can figure that out by just also looking at the top. 2, 4, 6, 12, 18. Okay. Now, how tall is it? How many layers are there? There's 2 layers, right? So 2 times 18. So that gives us 36. So there's 36 cubic centimeters, 36 cubic inches, and 36 cubic feet. Again, the numbers didn't change, just the unit measurement. Okay, so would the prism above be the same size if it were built with centimeter cubes, inch cubes, or foot cubes? No, the units aren't the same. No. So a foot is larger than an inch. Which is larger than a centimeter. Okay. So they're clearly not going to be. The largest prism would be the one that's cubic feet. Okay. All right. Let's look at number 1 on page 489. So use the unit given and find the volume. All right, so we're doing it in cubic centimeters, basically. So I can write cubic centimeters there. Now, what's the base? So I know that there's 4 this way and 4 wide. So that should be 16, right? 4, 8, 12, 16. So the base is 16. How many layers of 16 do we have? We have 1, 2, 3. So we have 48 cubic centimeters. In number 2, I have a base of 3 times 2. So how many do we have in the base? 2, 4, 6. How many layers of 6 do we have? We have 1, 2, 3, 4. So 6 times 4. So 24 cubic inches. Number 3. What's the base this time? We have a length of 6 and a width of 2. So there should be 12 in each layer. 2, 4, 6, 8, 10, 12. So our base is 12 square feet. Okay. Each layer is 12 feet. And there are 1, 2, 3 layers of 12. So we'd have 36 cubic feet. Okay, number 4. I have a length of 5 and a width of 4. A length of 5 and a width of 4. So that should be a base of 20. So 5, 10, 15, 20. Okay. So the base is 20 inches squared. And And how many layers of 20 inches square do I have? I have 1, 2, 3. So we have 60 inches cubed. Cubic inches. All right, number 5, compare the volumes. All right, well, this one has a base of 16. I'm going to just have to do 8 times 2. Okay, 2, 4, 6, 8, 10, 12, 14, 16. And I have a height of 2. So I'm going to multiply the base by 2. So 16 inches square by 2 inches tall would give me 32 cubic inches. And then on this one, we have a base again of 16. 4 by 4 is 16. 4, 8, 12, 16 inches squared. And we have a height of 2. So 32 cubic inches. So those two are equal. All right, number 6. We have a base of 9 by 4. So the base is 9 times 4, or 36 square feet. Okay, so I know that there's going to be 9 rows of 4 in each layer. So 36 square feet. And how many layers of 36 cubes do I have? I have 1, 2, 3. So 36 times 3 gives me 108 cubic feet. Right? And how about this other one? This one we have a base of 8 times 5. So there's going to be 40 cubes in each level. So 40 square feet. And there's only 2 layers. So we have 80 cubic feet. So 180 is clearly bigger than 80. Okay. All right, let's move on to page 490. All right. Gerardo says that a cube with edges that measure 10 centimeters has a volume that is twice as much as a cube with sides that measure 5 centimeters. Explain and correct Gerardo's error. Well, okay, so a cube with sides of 5 would be 5 times 5 for the base, which we saw in the investigation, and then 25 times 5 for the height. I'm sorry, and 5 for the height. So 25 times 5 would be 125 cubic units, or cubic centimeters. If we have a cube if the cube has sides of 10, it would be a base of 10 by 10. So that's 100, right? And the height would be 10. So 100 times 10, which equals 1,000 cubic centimeters. So basically, when he's saying that 10 is twice as much, and so the volume is going to be twice as much, that's not true. Each dimension will be twice as much. So each dimension would be 2 times as much. So 2 times 2 times 2 equals 8 times greater. Okay, so the volume will be 8 times greater. Number 8. Pia built a rectangular prism with cubes. The base of her prism has 12 1 centimeter cubes. If the prism was built with 108 1 centimeter cubes, what is the height of her prism? All right, so we would be using something like this. 12 times the height. So the base is 12 times how many layers would give me 108. Well, that's basically just 108 divided by 12, right? Okay. Because we know that division is the opposite of multiplication, and that if 108 was my dividend, my total, and 12 was one of my factors, I can divide 108 by 12. And I know that 12 times 9 is 108. So there's a height of 9 centimeters. Number 9. A packing company makes boxes with edges, each measuring 3 feet. What is the volume of the boxes? If 10 boxes are put in a larger rectangular shipping container and completely fill it with no gaps or overlaps, what is the volume of the shipping container? All right, so let's look at the first one. So we have a base of 3 times 3, because it says the cube is 3 by 3 by 3, basically. So a base of 9 cubic feet, 9 square feet, that's the base, and it has a height of 3. So 27 cubic feet. Okay, so each box is 27 cubic feet. We're going to put 10 of those boxes together in a larger container. So all we have to do is go 27 times 10. So that would be 270 cubic feet. Okay. 10 boxes, each measuring 27 cubic feet. And number 10. Carlton used 1 centimeter cubes to build the rectangular prism shown. Find the volume. All right. Our base is 4 times 3. So 12 centimeters squared. And how many layers of 12 centimeters squared do we have? In other words, the height. 1, 2, 3, 4, 5. 5 centimeters tall. So 5 times 12 is 60. So we have 60 cubic centimeters. Okay. So that's it for the volume discussion here. In our next lesson, we'll be working on how to estimate volume. So until then, I will see you soon.